might need such vehicle if you debug and develop computer vision autonomy in a real world. And this vehicle has on board Raspberry Pi 5, flight controller F405, 4 TT motors, 4 wheels. So this is 4VD vehicle. I personally use this particular vehicle to debug and develop my computer vision models with target following capability outside the room, on my backyard, because this vehicle works only when compass plus GPS signal is presented. As you may know, F405 flight controller has on board just only 1 megabyte flash memory size. It's enough to upload their Ardu pilot firmware with limitations, and it means that non-GNSS feature is disabled. But we might need non-GNSS feature to work with autonomy. Autonomy, I mean guided mode, first of all, when Raspberry Pi as a companion computer can control the vehicle. So you might need to use vision position estimate feature, which is not included in default build. When you try to build the rover, which can operate inside the room, so this particular vehicle can operate only outside, on backyard, when GPS and compass signal is presented. But today's video will be about building the same vehicle, but with a target to use that vehicle inside the room with no non-GNSS environment. And for that I prepared another frame. I already installed here 4 TT motors, yellow motors, 4 wheels. So let's start. I described how to build such vehicles, and not only the Rover, but also some other vehicles like fixed wing aircraft with autonomy, and FPV copter, in this book, AI-driven Autonomous FPV Drone Development. And today we will use the detailed instruction in chapter 6, which called Rover. Here we have the schema and all the necessary explanations how to build this vehicle, this car. So for my personal goals of debug and development, computer vision for autonomy, for vehicles autonomy, I will use this particular one for outside work on backyard, and this particular one for inside work when no GPS signal, where no compass, and actually it will be helpful to use the computer vision for target following, for example, in environment where anti-drone systems applied. Okay, to build such rover, we will need to use this frame with 4 TT motors, 4 wheels. Then we will need drivers like this. It's BTS 7960 to control power on our motors. We have to supply our TT yellow motors with 6.5 volt voltage and 2.5 ampere current, and for that purpose we will use this BTS 7960 drivers. One driver for left side of the rover, left wheels of the rover, and another driver for right side. Then we will also use this flight controller, which is PDB F405 version 3, capacitor, XT60 cable, this DC to DC converter, because our battery pack has a voltage 14, I think 1415, so it's for S1P, lithium-ion battery, and on its input we will have 1415 volts, and on its output we will need to have just only 6.5 volt and 2.5 ampere to supply our motors with an appropriate voltage and current. Also, here we will use this ELRS 2.4 gigahertz receiver to control the vehicle. It's gonna be an initial setup, and in this video we will just only build the vehicle, but in the next one I will communicate it, I will integrate it with Raspberry Pi 5 and the computer vision model for target following inside the room. It called like non-GNSS environment. And here I have different wires which I will use to build this vehicle. Okay, here in the book we have first motors and drivers layer, and this is what we will have on the first step. So this is 4 TT motors connected to two BTS 7960 drivers, and then we will connect the drivers to the flight controller like it showed here. So I will actually use this detailed guide. Okay, first of all we need to build the power module. This is the DC to DC converter. On its input we have the battery pack, 1415 volts, and we have to connect it to the converter accordingly with capacitor, and it's to power our motors. We will use this to power our motors. Also we will connect here these two wires for flight controller powering, for powering flight controller directly from the battery pack. So flight controller powered directly from the battery pack. So the this connection will be in parallel. Here is also capacitor, black to minus of the capacitor, red to plus of the capacitor. Here I have little bit isolated the wires which is connected to our capacitor. So the black one to minus, the red one to plus, as we can see here. And now I will just put it in these connectors to connect them. Okay, now we have to check our connections. For this purpose we will use ampere meter, multimeter. Here in this position it must be, and then on our display we have one, and now I will check it. As you can see in here, 654.55 volt is set up. 2.49 ampere also configured in here. Okay, what we have in here, these two wires, which is plus 6.5 volt and 2.5 ampere, and these two wires, it's ground, and we will use them to power up the BTS 7960 drivers for our motors. On this side we have capacitor, we have wires to power the flight controller exactly. XT60 is our battery pack connector, and with two regulators we configured these parameters for DC to DC conversion. I always use an additional isolation. So our power module is ready. Here we have XT60 connector to connect to the battery pack. Here we have two wires to connect directly from the battery pack to the flight controller, and here we have powering for BTS 7960 drivers for one and for another one. First step is completed. So power module for our new Rover is completed and to be continued. See us in the following videos.